All the big important things that you guys learned in grade 10 about exponents is what we are going to be taking a look at. Okay, so let's just go over, let's like refresh our minds. Let me, I'm just going to zoom in a little bit here. That's a bit better. Okay, so we're just going to go over some definitions, make sure we're talking about the same language. Okay, so when we're talking about exponents, okay, that's like the little number up on the side. The whole thing is called a power. So if I say like what, you know, when we're talking about powers, okay, the whole thing is called a power. The number on the bottom, that is called our base. Okay, so we just need to, okay, we basically have a base and we have our exponent that makes up the power. Yeah, just save it for later. Okay, so guys, a base with no exponent, this is where our invisible math comes from. So remember, do I have it up here? Yeah, the pink one way over here. Every number has an exponent of 1. Okay, so if there is no exponent, then we can always have an exponent of 1. Okay, because anything to the power of 1 is just whatever that number is. It's kind of like when we multiply by 1, right? It's just the original number. So just make sure that, like say we had, for example, say we had an x. What's the exponent on x if I didn't write anything in? 1. Okay. When a power has a negative base, the base has to be put in brackets, guys. Okay. So this, okay, if we were to expand this, okay, remember back when we talked about like, well, what does an exponent mean? When we square something, we're basically taking it when we're multiplying it twice. This one is to the exponent of 4, which literally means that we would take -6 and we would multiply it by itself 4 times. Okay, that's what the exponent, okay, that's what the exponent in expanded form means. If you were to have left the negative outside, if there was no brackets, okay, this actually means that the negative gets left out in the cold, okay, and we multiply 6 by itself 4 times, which gives us a very different answer. Well, it gives us a similar answer, except this answer is positive, because a negative times a negative is a positive, times a negative is negative, times a negative is positive. Like if we have an even number of negative signs, our answer is positive. But here we have an odd number of negatives, so our answer is negative. So you would get the question wrong if you didn't put brackets around your number. Okay, so this is not the same, okay, not the same as, not the same as -6 with brackets. Okay, so just be mindful that if your base is negative, please put brackets around it. All right. Okay, here are the exponent laws that you would have learned back in grade 10. Okay, so let's review them, kind of make sure that we remember how to use them. So the laws go like this, okay? If you multiply, and some of these like you guys already know, okay? I'm just making sure that we're writing it down and using the same language. We have something called the product law. When you have the same base and you're multiplying those bases together, what do we do with the exponents? Yeah, we add the exponents. Okay, so this one has an exponent, oh, sorry, let me put the base in. Okay, we're gonna add the exponents together. Okay, you guys were already doing this when you were distributing, you know, and doing the multiplication, and you had like 2x times x, and you knew that was 2x squared. Okay, you were actually adding those exponents because your x had a little 1, and you were going 1 plus 1 is 2. Okay, maybe you didn't think about that, but that's actually what was happening. Okay, a quotient law, quotient is just a fancy word for saying division. Okay, when we have a base and we're dividing the same base, okay, anybody know what we can do with our exponents? Yep, we're going to subtract the exponents. Okay, do you guys remember power of a power? Do you guys remember power of power? Okay, when you have an exponent on the outside of a bracket, okay, what happens here is, okay, that exponent, right, gets, it's almost like it gets put into the brackets. So this is where we multiply our exponents. So we would have x, and we would go m multiplied by n. Okay, we're going to write all these down, and then we're going to do some actual examples. I think it's easier when we see numbers with this. Okay. Power of a product is just an extension of power of a power. It just means that everything inside of the brackets gets that multiplied by that exponent. So because these are little ones, right, our invisible math, because there's ones, we just go 1 times m, which gives us m, and each of them get the multiplied by the m. And then the quotient, that it's the same thing. We could separate this out, and we could say x to the power of m divided by y to the power of m. Okay, so they each get that exponent m. 2 more. Okay, what is anything to the power of 0? 1. Oh, it was a good try. Okay, anything to the power of 0 is going to be 1. So if I said, what is 3,582 to the power of 0? It would be 1. Okay. If you had something like crazy, exciting. Okay, guys, if you had this, okay, that means everything in the brackets counts as just one big thing, and if it's raised to the power of 0, it's 1. You don't have to do anything with the inside brackets if the brackets have an exponent of 0. Our final one here, what did negative exponents mean? Anybody remember that? Negative exponent. Okay, thank you. Okay, it's been a while, hasn't it? Okay, negative exponent just means that you take the base and you flip the base, right? You write the reciprocal of the base. So this is, well, let's write the base. 1 over x. Okay, so the negative sign just means that you flip the base. Okay? Okay, so negative means flip. Okay, guys, what about this though? Okay, what happens if I have, here, let me move this up a little bit so I don't stand right in front of it. Okay, what happens if I have this? I have, oh, here's like a summary of this. When you're doing all of your questions, okay, the convention is that all of your exponents are going to be positive. If your answer, like as you're doing your math, sometimes you'll get one of your exponents being negative. What that means is before you put it in a box, you have to turn it into a positive, okay, by writing the reciprocal. Sometimes what happens is you have this. You have x to the negative 2, maybe with a y to the power of 3. Okay, only the x has the negative exponent. So this means that only the x pops down to the bottom. You guys remember that, or it's been a while? It's been too long, okay? I'll treat it like you guys are brand new to this. I'm okay with that. So this, okay, if this was your answer, x to the negative 2, y to the power of 3, before you give like your final answer, you have to make sure all of your exponents are positive. So your y to the power of 3, let me clean that up for you. So it looks like a y. Okay. The x would pop down to the bottom, and that would take care of the negative. So now my exponent is positive. Okay. What do you think happens? Okay. What do you think happens if I have this? Okay, what if I'm simplifying and I get to this answer? I'm almost ready to write my final answer. But the y is already on the bottom, but now the y is negative, has a negative exponent. Okay, how do we flip that? Yeah, okay, I like the hand gesture. What happens is, okay, the y gets flipped to the other side of the bar. Yeah, so this becomes x squared. Okay, so we have to take care of this negative sign before we have our final answer. So depending on where the variable is, there's only two options. The variable is either on the top or on the bottom. Okay, and if it's negative on the top, you just pop it to the bottom. And if it's negative on the bottom, you just pop it up to the top. Okay, let's try some examples together and see how we're doing. Okay, guys, here we go. A, I want you to try it first. Okay, you're multiplying. Okay, the bases are the same. So this works because they're both x's. And what do we do with our exponents? Add them. Okay, you guys have to be really good at adding and subtracting and multiplying integers. Okay, how about this one? Same base, so we double check. Okay, same base, and now we're dividing. What was the rule when we divide? What? Yeah, we can subtract our exponent. So 6 subtract 2. Okay. All right, this one was called power of a power. Okay, when you take an exponent of an exponent, what do you do with those exponents? You multiply them. Yeah, absolutely, guys. Okay. Okay, x to the power of 20. All right. Okay, now we've got, okay, don't forget that this bar, okay, I'm going to go back to this page. Guys, this bar is just a different way of writing a division sign. Okay, so this is a division sign. So for example, okay, so how do we put, what do we do with this to the power of 3? We have brackets and it's raised to a power. Okay, this is this one right here. It says that everything inside the brackets gets multiplied by that exponent. So we're going to have x to the power of 3, y to the power of 6, because we're doing 2 times 3, right? Power of a power. All right. Our final one, guys. What do you think should happen to our coefficient, to our 3? You got to raise it to the power of 3. Okay? Is it what? You're close. Okay, guys. What is 3 to the power of 3? No. 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 27. Yeah. Yes. Okay. Okay, so everything inside the brackets, yep, have a good time with your photos, guys. Okay, everything inside the brackets gets raised to that exponent. So don't forget that you're not going 3 times 3, you're going 3 to the exponent 3, okay, which is 27. Okay, so if you need to, like, go ahead and pull out your calculator, right, and you can do 3 to the exponent 3 just to make sure. Okay, so we're going to simplify the following, and here it reminds us, record your answers with positive exponents. Okay, so if you're feeling good, why don't you get a head start? X to the negative 3, what does that mean again? Okay, remember to get rid of the negative, we're just going to flip the base. Okay, so right now x is on top, so we're going to put x on the bottom. Okay, and the exponent goes with the x. but now it's positive. That's just the definition. Like that's what a negative exponent does. Yeah. Well, how does addition happen? Like, that's just what it is. That's the definition of it. That's like what happens. I'll come up with an example to like help out. Okay. But like, why? Like, this seems weird. Yeah. Yeah. It is. It's different than the other ones for sure. Okay, so guys, when you have this, remember, you're basically doing this. You're multiplying. Okay, you guys should be taking amazing notes. You should learn by now that having complete notes really helps you out on your chapter test, right? Okay, so you're going to multiply the numbers. So you have 8. Okay, guys, we have the same base. So what do we do when we multiply the same base? What do we do with our exponents? Add them. What's 3 plus -4? Yeah. So this is the in between. Okay, so now, because we have a negative, the x has to drop to the bottom. So it's going to be 8 over x. Okay, we could, okay, the 1 can be there. The 1 is optional. Okay, you don't have to write the 1. You won't lose marks for writing it or not writing it because they mean the exact same thing. Okay, so I would take 8 equals x to the power of 1 or just 8 over x. Okay, so try this next one. Okay, we're going to do 2 to the -3. We'll take a look at that. And then when we multiply, 4 times -3 is -12. Okay, so that means that both of these, if we were to draw the bar, both of these have to drop down because they're both negative. So we're going to end up with 1 on the top, okay, because something has to live on top, and a 0 doesn't. Okay, so 1 on top, and now we have 2 to the power of 3 and x to the power of 12 on the bottom. So when we put them on the bottom, that gets rid of the negative sign. Okay, that's the definition of like what to do with a negative exponent. Okay, now guys, what's 2 to the power of 3? I don't want you to keep it in this form. I actually want you to like give me the number. Yeah. Yes. Oh, this one? This one. Oh, no. No, you don't have to. You would want to take care of the negatives at the very end. Yeah. Yeah. Okay, so guys, this I would want to see 1 over 8 x to the power of 12. Make sure my 12 looks like a 12. Come on, little guy. There. All right, and the final one here. Okay, so we have a 5. Guys, same base. What are you going to do with the exponents when we divide? You're going to subtract. Okay, guys, you may, like, please mental math, but please double check your calculator. If you're adding and subtracting with negative exponents, puts you in jeopardy of getting the wrong answer. Because look at this. When we go -3 subtract -2, what happens when we subtract a negative? Yeah, do you guys remember, did your junior high teacher ever teach you like bang, bang? No? Okay, when you see 2 negatives, you go bang, bang. Okay, and the negatives, 2 negatives become a positive. So this actually becomes -3 plus 2. So this is 5, okay, to the -1. Okay, which means that you got to move the x to the bottom. Okay, guys. Okay. How about we use polite language? Okay, guys, you need to memorize these. If you don't already know them, okay, you need to know what happens with all of your exponents. You guys didn't learn that? Oh, well, yeah, it's got a good alliteration. Come on in, Clara. All right. All done?
I just have questions for 7 and 9.
Okay.
Would you rather me ask that next period since I have you?
Sure.
Okay.
Yeah.
Thank you.
All right, our final thing for today, and then we're going to get you guys doing a little bit of board work, a little bit of practice, okay? Actually, let's do a little bit of board work right now, okay? All right. So our exponential equations, okay? Remember what an equation means. An equation just means that there's an equal sign as part of the question. So when we did rational expressions, we also did rational equations, okay? And that meant that we used these expressions, but there was an equal sign in there as well. So an exponential equation is just where the variable is in the exponent. So for example, if you guys were to, because we just finished polynomial functions, right? Where we had like y equals. You guys learned linear, y equals ax plus b. Okay, we did quadratic, y equals ax squared plus bx plus c. We did cubic. This one's an exponential. This one's going to look like this. Y equals 2, and this time the x is up in the exponent. Okay, that's just what an exponential function means. Okay, so here's how we solve these. Okay, we want to solve for x. So when you see an equation, okay, so one thing is there's an equal sign. Okay, and the second thing is we're trying to solve for the variable. In all of these cases, we're trying to solve for x. Okay, and when you guys were doing, right, junior high, grade 10, grade 11, right, we always put like x on one side, everything else on the other. So this is no different. Okay, right now we have x on one side. However, it has this exponent. Okay, don't worry that the exponent is a fraction. We haven't, okay, your calculator can handle the fraction part. But what we're going to do is we want the x to be all by itself. And the way that we do that, remember when we have an equation, whatever you do to one side, you have to do to the other, right? You have to keep your equation balanced. So if you were to like add something to one side of the equation, you have to add it to the other, right? If you were to subtract something from one side, you'd subtract from the other. Same with multiplication and division, same with work with our exponents. So what we're going to do is, in order to get rid of this 1/2 on this side, okay, we're actually going to, okay, put brackets around this, okay, like everything that has the 1/2, okay, and if we were to multiply by its reciprocal, okay, reciprocal just means flip. If we were to multiply 1/2 by 2/1, what is our answer? Like, no, like just this, the exponent part. 2/2, which is the same as 1. Okay, the goal is to get this equal to 1. Okay, so if we multiply whatever the exponent is by its reciprocal, okay, that will get us to an exponent equal to 1. Okay, so our goal is to get our exponent Equal to 1. Because if it's equal to 1, then we have x all by itself. Now, what I did to one side, guys, I got to do to the other side. I took that whole left side and I raised it to the exponent 2 over 1. I'm going to do the same thing to the right side. That's it. Okay, guys, what is 2 over 1? 2. Do you know what 7 squared is? 49. Okay, you can do that in your calculator. Okay, so this ends up being, actually I want that one in purple. Okay, so this ends up being x to the 1, right, when we multiply these, okay, which is just the same as x, okay, and this is equal to, okay, x squared, which is 49. Guys, how could we check that? Could we go back to our original equation and just sub in to the original equation? Could you go 49, like with your calculator, could you go 49 to the exponent 1/2? Okay, and it says the answer is 7, which is what the right-hand side is equal to. So that means that we successfully isolated for x and solved for x. And we checked it by putting it back into our original equation. Okay, in this one, okay, what we're going to do first is we want to isolate for x and whatever exponent it has. Right now, there's a 2 hanging on to the x. How is the 2 hanging on? By multiplication. How do we undo multiplication? We do some division, exactly. So this one, okay, the first thing that we're going to do is we're going to divide both sides by 2. Okay, to get rid of the 2 on the left-hand side. Okay, whatever you do to one side, you have to do to the other. So our goal is to have x all by itself. Okay, and x had this tag along 2 that was being multiplied. So if we divide it by 2, now we have, this is what we have now. This is what we have now. We have x by itself to some exponent, and then we've got this negative 1/2 on the other side. Okay? What we're going to do is we're going to multiply everything on the left-hand side by the reciprocal exponent, because we're trying to get x to the power of 1. Okay, so if we multiply everything by 3 over 1, 1/3 times 3 over 1 is 3 over 3, which is the same as 1. Okay, what I do to one side, I have to do to the other. Okay, I'm going to keep that 1 there so you know that I'm doing exactly the same thing to the other side. Okay, so this becomes x on this side. Guys, you can do this one with your calculator. Okay, or you can math it out. Okay, so this is just negative 1 over 2 cubed. So 1/2 times 1/2 is a quarter, times another half is an 1/8. Okay, if you're to use your calculator, guys, I don't want decimals. You have to just math fraction it back to a fraction. Okay, so this is what this one would look like. So on your calculator, you can do, okay, you can do your fraction, your stacked fraction. So you have negative 1 over 2 to the exponent 3. Okay, boom. Okay, it gives you the negative 1 over 8. Okay, if your calculator gave it to you as a decimal, just use math fraction to turn it back into a fraction. Okay, so this is equal to negative 1 over 8. If we wanted to check that, we could. We just go back to the original question, and you go 2 times negative 1 over 8 to the exponent 1 over 3. Okay, so we could totally check this out. 2 times, okay, negative 1 over 8 to the exponent 1/3. Okay, and it gives us the answer of -1. So we've just verified. Okay, we just verified our answer. How you guys feeling with this? Okay, why don't you try the next one in your notes? Okay, so this one's just like B. You're going to divide by 5 on both sides first. Okay, we want just x by itself. Okay, I'm thinking maybe some written out steps might be helpful. Okay, so I'm just going to, while you guys are trying C in your notes, I'm going to just write out some extra steps. Okay, so the first step, you should have isolated for your x by dividing by the number in front. Okay, by dividing by the number in front. Okay, your next step. Okay, guys, the next step is to multiply both sides, okay, by the reciprocal exponent. Okay, because the whole point is so that we get to x to the power of 1. Okay, if the exponent is negative, take the negative with you. Okay, so in this example here, our exponent is negative, so we're going to, okay, put everything in brackets. Okay, and we're going to multiply it by, okay, the reciprocal. Okay, the whole point of that, guys, is this has to equal 1. So if you're not sure, okay, you can use your calculator, or you could just look at this and say, okay, I've got a negative times a negative, which is a positive. I need a positive 1. Okay, 2 times 3 is 6 on the top. 3 times 2 is 6 on the bottom. 6 divided by 6 is 1. Okay, so if you multiply an exponent by its reciprocal, you will always get the answer of 1. That's why we choose to multiply it by its reciprocal, right? Where we flip the reciprocal is just a fancy math word for flipping. Okay, now we have x to the power of 1. Guys, go ahead and put that into your calculator. Yeah, so you'll probably either end up with the decimal, or it'll give you, okay, it'll give you 1/27 as your answer. Okay, so guys, 2 steps. Your first one is, if there's a number in front of the x, you're going to isolate x by dividing by that number. Okay, then you're going to use the reciprocal exponent so that you can get x to the power of 1 and solve your equation. Okay, so that's what we did here. Okay, we've got D. Okay, D's on you guys. Okay, so give D a try. Picking up where we left off, guys. Guys. Okay, check your work. Okay, we should have divided by both sides by 4. I should leave a little bit more room here, actually, just to... There we go. All right, 4 to the power of -3. -3 divided by 2. Okay, math fraction. Okay, 1/8. Did you get it? Okay, awesome. Okay. All right, my friends. Okay. Yes. Yes. Okay, what I want for us to do is, I'm looking at our homework questions. Okay, guys, go ahead and pull out your workbook. We are going to be doing the questions on the bottom of the page, 194. I will do these examples tomorrow. Okay, I want to give you some time to work on your practice questions and ask me if you need some clarification.